Okay, we're back as promised, and in this video we're going to use our favorite tool, completing the square, to put a circle given here in standard form. And recall from earlier videos that with completing the square, we've showed a long time ago that anything in the form of x squared plus bx can be written as x plus b over 2 squared minus b over 2 squared. Okay, so that's going to be our little toolbox for this one. And again, if you're still rusty on that, just multiply this stuff out and you'll see you get x squared plus bx. And so it's a nice way that when you don't have a perfect square here, you can make a perfect square, but then you have to use this negative b over 2 squared as an adjustment term because you actually didn't have a perfect square in the first place. So let's work this out. I'm going to go in green here. And so first I want to complete the square on this term. And so that's going to be my b is 4. So I have what, x plus b over 2 is 2 squared minus b over 2 squared. That would be 4 over 2, which is 2, and I square it and I get 4. Okay? And now let me switch colors here. Let's go in yellow. Complete the square on this term. We get my b is a negative 6, so I'll get y plus b over 2, and negative 6 over 2 is a negative 3, y minus 3 squared, and now I need to subtract 9. That is b over 2 squared would be a negative 6 over 2, which would give me a negative 3. I square it, I get 9. So it's minus 9, and we equal 12. Okay? So now we've got x plus 2 squared plus y minus 3 squared equals, what's that going to be, 12 plus 13 equals 25. Okay? So in my standard form that would be x plus 2 squared plus y minus 3 squared equals 5 squared. And so I get my center is at negative 2, 3, and my radius is 5. Say r equals 5. Okay? And so I want to emphasize again, this method of completing the square is not going anywhere. You guys need to know how to do this. And it's going to come up in Calc 1, Calc 2, differential equations, Calc 3. You're going to be completing the square for the next couple years. So the quicker you get it down and simplify it for yourself, the better you're going to be. And this is the quickest and easiest way to do it. You just have to make that make sense for yourself. Okay? Let's talk about something else here with circles. Let me draw a circle. So is that a circle? It's almost a circle, huh? And so let's say I have a center here, and let's go all the way across, and that's going to be my diameter. So that's going to be my diameter D. What we're going to talk about now is what folks found a long time ago. If they would make circles, and then they would take there's my diameter D, and then they would lay out the circumference here and try to lay it out. And what they found, no matter what the size of the circle, was that always it was something close to second of those diameters, and then a third of it would always fall right around the end. We've been sloppy here. So for a long time it was thought that 3 times the diameter equaled the circumference C, the circumference around the circle. They knew it was something close to 3 of the diameters equaled the circumference. It turns out, as many of you may know, that it's actually not 3, but it was a little more than 3, and so then a guy named Archimedes gave us a better estimate of 3.14 times the diameter equaled the circumference c. Okay, and then as we know now, that number's it's actually not 3.14. 3.14 is a great estimate, but it's actually the irrational number pi times d equals the circumference. Okay, and so we will get that the circumference, usually you'll see it in this form, you instead of writing diameter, so here's the radius, and so the diameter equals 2r, and so that the circumference of a circle c equals 2 pi times the radius, and that's where that comes from. And again, it really was, it started out with folks would do their best to take a string and make a circle, and then they would lay out that string and then lay out the length of the diameter, and they always found that it was about 3 of these, about 3 of the diameter equaled the length of the circle. So about 1 diameter, 2 diameters, 3 diameters would always end up, give or take, somewhere around here about the end of the circumference. And so that's where we first got this estimate of 3 times the diameter equals the circumference of a circle. And then Archimedes got us to about 3.14. I challenge you to look up how Archimedes did that. It's a really interesting method. And we know now that it's actually the irrational number pi, which is 3.14 and some change, and the decimal never repeats. So we get the circumference of a circle is 2 pi r. Okay? Hope you enjoyed that one. I will see you in the next video.